Okay. All right, here we go. Guys, thumbs up that you hear me and see the board okay when I'm not standing in the way. All right, here we go. So we are graphing quadratic equations for the last time today, like together. Tomorrow you're going to practice completely on your own. However, I kind of went back and forth about this. When you are graphing a quadratic equation, I'll be the first one to admit that the process is long and you can make a lot of mistakes along the way. I get it. But there is a shortcut. And I was going back and forth whether I show you guys the shortcut or I don't show you the shortcut. Every year I always show it, but this year just being that, is it going to be okay virtually? Will they see it? So I'm going to show it to you so that if anybody is looking for a shortcut to any of this, maybe this will be better for you. But if you're somebody who is like, I really like my table, then keep doing what you're doing and you'll be fine. But I'm going to show you the pattern and then you guys can choose whichever one you like best, okay? All right, so fortunately, these parabolas, these U-shaped graphs, they actually go up and down following a very specific pattern. So the pattern says you always move right or left one space at a time. You go right one, right one, right one, left one, left one, left one. But these parabolas actually move up or down following the pattern 1A, 3A, 5A, 7A, 9A. And that A is the number in front of x squared that we've been using all along. So they actually, it looks like the odd number pattern in a way. They actually will always go up or down following that pattern. So I've given you a bunch of parabolas that are already graphed. I just didn't connect the dots because I wanted you guys to see the spaces and I didn't want the lines in the way. So I'm going to show you that the pattern does work. So guys, here's a parabola with an A value of 1 that's already graphed. So if you notice from the vertex, I go to the right one space, it goes up one space because that's the 1A out of the pattern when A is 1. 1 times 1 is 1, you go up one space. Then from this dot, I go to the right one, and then I go up 3 spaces because that's the 3A out of the pattern when A is 1. 3 times 1 is, you'll go up by 3 jumps. Then I go right 1, and this time I went up 5 jumps because that's the 5A out of the pattern. 5 times 1 is 5. Then I go to the right one, and I had to go up, if you look, 7 jumps because that's the 7A out of the pattern. When A is 1, 7 times 1 is 7 jumps. And then I tell you, the next one will go right 1, up 9, right 1, up 11. And it's the same thing on the left, except I go left 1, up 1, left 1, up 3, left 1, up 5, left 1, up 7. So in the beginning, it can be deceiving that students are like, oh, it just goes up by the odd number pattern. Not technically. This one only goes up directly by 1, 3, 5, 7 because A was 1. It goes up by 1A, 3A, 5A, 7A, and whatnot. So guys, here's another parabola. This one goes down, but now his A value is -1. So if you notice from the vertex, I went right 1, and I went down 1 jump because that's the 1A out of the pattern. 1 times -1 is down 1 jump. I went right 1 again, and then this time I went down 3 jumps because that's the 3A out of the pattern. Thank you, Bettina. All right, 3 times -1 would be -3 jumps. I went right 1 and I went down 5 jumps because that's the 5A out of the pattern. 5 times -1 is -5. I went right 1 and I went down 7 because that's the 7A out of the pattern. 7 times -1 is down 7 jumps. So guys, it works. So if you want to use the pattern, you won't have to use the table anymore. You won't have to plug numbers in to create these ordered pairs because you're going to get your ordered pairs just by counting the jumps, okay? All right, let me show you one when A is 2 and how the pattern still works. All right, guys, here's a parabola that went up with an A value of 2. So if you notice, from the vertex, I went to the right one, and I went up 2 jumps, because that's the 1A part of the pattern. 1 times 2 is 2 jumps. I went to the right one, and now I had to go up 1, 2, 3, 4, 5, 6 jumps, because that's the 3A out of the pattern. When A is 2, 3 times 2, 6 jumps. I went right 1 and up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 jumps because that's the 5A out of the pattern when when A is 2, 5 times 2 is 10. So it works every time. If A is negative 2, it's just going to be the same pattern, but going down. So write 1, down 2, because that's the 1A, 1 times negative 2. Write 1, down 6, because that's the 3A, the 3 times negative 2. I went right 1 and down 10, because that's the 5A. 5 times negative 2 goes down 10 jumps. Does that make sense? Can you guys see it as it's happening?
Yeah.
Okay. All right, let me show you when A is 3, and then we're going to try it. Now, you guys will see that the bigger A gets, as A gets like 3 and 4 and 5, the space in between, you have to make bigger jumps. So you can't fit that many dots on one graph because they get big so fast. But we're going to give it a go anyway. So when A is 3, on this parabola, I went to the right 1, and I had to go up 3 jumps because that's the 1A part of the pattern, 1 times 3. Then I had to go right 1 and up 1, 2, 3, 4, 5, 6, 7, 8, 9, because that's the 3A out of the pattern. 3 times 3 would be 9 jumps. And then, guys, I'm telling you, the next one will be right 1 and up 15 jumps, because that would be the 5A, 5 times 3, but clearly it ain't fitting on our graph. But it works. Same thing. If A is negative, it's the same number of jumps, but you have to do them going down from the vertex instead of going up. So this would be right 1, down 3, because that's the 1A part of the pattern. Right 1, down 9, because that's the 3A, 3 times negative 3, part of the pattern. All right, so what I'm going to do is I gave you, I think, a Word doc on your notes. That's the one I gave you guys. So we're going to try to do 2 of them using the pattern. And then you can decide whether you want to use the pattern or you want to stick with the table. Your call. All right, so now the Word document. Okay. All right, let's give it a try. So now we're going to graph this parabola. Y equals negative x squared minus 4x minus 2. So in this problem, A, the number in front of x squared is negative 1. B, the number in front of x is negative 4. And C, the number by itself is negative 2. So this parabola is going to open down because A is negative. So now we have a visual, and that just means you should be counting those pattern jumps down from the vertex. All right, let's get our vertex. Unfortunately, you still got to do that. We got to do the opposite of B over 2A. So the opposite of B is 4, divided by 2 times A, which is negative 1. So that's going to be negative 2. 4 divided by negative 2 is negative 2. So now we know the x-coordinate of our vertex is negative 2. And unfortunately, even with the pattern, you're still going to have to do at least one plug-in to find out the y-coordinate of your vertex. So let's plug negative 2 in. So remember, that negative is not part of what you are squaring, so leave it on the outside. Then plug in negative 2, square it, minus 4 times negative 2, and then minus 2. Plug that into your calculator, or you're going to get negative 4 plus 8 minus 2, 4 minus 2. You get positive 2 as your y-coordinate. So that makes your vertex the point negative 2, positive 2. So throw it on the graph as soon as you get it. Left 2, up 2. All right, now they want the AOS, that imaginary vertical line that goes right through your vertex and cuts the parabola in half and says everything on the right side will match everything on the left side. All right, what is the equation of that AOS? It's the vertical line, x equals, what is the x-coordinate on that line? Negative 2. Right, they always match. All right, now guys, this is where you're going to make a choice. This is where you're going to be like, I'm sticking with the table. And you're going to put your vertex in the middle, pick 2 to the right, negative 1 and 0, or negative 3 and negative 4 to the left. And then you're going to plug them in and figure it out. Or you're going to try the pattern. Let's get ourselves set up for the pattern. The pattern relies on the A value, the number in front of x squared, which we said is negative 1. And then the pattern goes by 1A, 3A, 5A, 7A. But guess what? I never make you find 5A and 7A. I only make you do 1A and 3A because those will get you enough points to graph. All right, here we go. If A is -1, 1 times -1 is -1. That's the first number of jumps away from the vertex we're going to make. 3 times -1 is -3. That's the next number of jumps away we'll make from whatever point we're at. All right, let's do it. Let's do it. All right, so remember, these numbers only tell you how much the parabola goes up or down by. Right or left is always just one space at a time. So go to your vertex, go to the right one to the next x value, and jump down 1 unit first. And then you can match it on the other side, or you can move to the left one and jump down 1 as well to match it. All right, now, don't go back to the vertex. From this new point, from this point that we're at, go to the right one to the next x value, now jump down 3. 1, 2, 3. And either match it or go to the left and jump down 3 from him. And there you have it. There's your parabola. So if you think that's something you might like, it will work every single time. That is the pattern that a parabola will go up or down by. All right, now, if you were a table person, then anybody who plugged -3 or -1 in would have gotten +1s to come out. And anybody who plugged 0 or -4 in would have gotten -2s to come out. That's what your table would have looked like, and you would have gotten the same 5 dots as us. Okay? Oh, my Chromebook's going to die. Hold on. We're good. We're all good. Got cords everywhere. All right. Now let's answer a couple questions. Well, first of all, hold on. Thumbs up if you're like, okay, that pattern wasn't too bad. I might consider it in the future. Is everybody all right? Okay. All right. Here we go. Max or min? This parabola clearly is going down and getting low, 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 low. No min, but it definitely has a high point. This one has a max. All right, the y-intercept. Well, lucky for us, it crosses the y-axis right there at 0, -2. So I can see it on the graph. All right, the x-intercepts. It looks like we're going to have to make an estimation. The x-intercepts, or the roots, if you will, it crosses the x-axis twice, here and here. So we're going to have to guess. This one is somewhere in between 0 and -1. So any decimal between 0 and -1, we will mark correct. I'm going with -0.5. It looks pretty close to the middle. And then this one looks like it's -1, -2, -3, -4. It looks like it's in between -3 and -4. Now again, my line could be a little wrong. I'm going to go just based off where it is. I don't know, -3.1, -3.2. But again, anything in between -3 and -4 will mark correct. So I'm going to put ish. Right? Because we're just estimating. That's a very technical math term. The domain. What is the domain always? All real numbers. Eventually, you could just keep plugging x values in and create more points where all real x values would live on this graph. The range, though, the y values, guys, all of these y values are going to keep on going down all the way to -infinity. However, the highest y value is definitely 2, and all of the other y values are smaller than him. So that would mean the range is y is less than or equal to 2. Okay, now before I move on to the last problem, let you guys go, I just want to show you something. I was originally, for homework, going to give you guys a Google Slides presentation to do for homework. You were all going to get your own Google Slides to graph on, because I'm having trouble finding decent graphing problems to assign you. The next assignment on Delta Math, it had vertexes that were in the 1000s, and they wanted you to change the y-axis to count by 100s and give it a different scale. And it just made it way more complicated than it needed to be. So I didn't want to assign that. So I made a Google Slide presentation. Let me just show you what it is. What period are we in? 7. Okay. I made this, which again, I don't know if I said it yet, but spoiler alert, I'm not giving you guys homework tonight. We're not giving you homework. I'm actually going to wait till tomorrow and let you do it in class. But this is what it's going to look like tomorrow so that you guys kind of know what to expect. So you're going to be given a parabola to graph. This is the one we just did. We literally just, I still have the numbers up here. All right. I gave you 5 pre-made black dots that you're just going to have to drag to the correct ordered pairs to create the parabola. So you're going to have to do like scratch work on a separate piece of paper. but you're going to graph a parabola using those black dots. So watch. I would just go over, grab a black dot, drag it to my vertex.
I know what you did, but you dragged the blue then.
The dot turns blue.
Oh,
yeah.
Okay, sorry.
And then I'll drag it to another point as best I can. It's not going to look anything great. And then here. It's not that easy, guys. Wait till you try. All right. And then there's your parabola. And then I said you do not have to connect the dots because I can't figure out how. So I can't figure out how to make a curved line to actually curve and go through all these dots. So I said you don't have to connect them. And then I asked you to label the vertex. So you just click where it says type answer here. And you either can erase that or write in the box. Doesn't matter to me. -2, 2. I should change the gray font so that you can read it. And then your AOS was the line x equals -2. And then you would go on to the next slide and graph the next one. Does that seem easy enough? Everyone okay? All right. All right. Just because, like I said, Delta Math got to be a nightmare, and I thought this might be a little bit easier for you guys to graph. So I was going to give you it for homework, but I ended up not assigning it. I'm just going to give it to you guys tomorrow in class. So I'm going to make you guys stay on the Google Meet tomorrow, and you're going to work on these slides. And as you finish your whatever many problems I assign you, you can like, hey, Miss Hardy, I finished. I'll look at your slides, and you'll be good to leave the meet, okay? Now, just while we're talking about this, because of how everything is lining up, I just want to give you guys a little bit of a game plan. Tomorrow, I wanted to give you guys one day to practice the pattern in case you liked it and wanted to try it. But that means we kind of finish tomorrow. Then we have a 3-day weekend. Yay! But I think you're going to have to come back on Tuesday to a quiz. And I hate to give you guys a quiz after a long weekend, but you're going to be taking it at home, so it really shouldn't matter. Anybody who comes into school can wait till they go home and take it. But I want to quiz you on the standard form before we move on to the next form and change everything up. Well, we don't change that much up, but still. All right? So I apologize, but it looks like you may be coming back to a quiz on Tuesday. All right, here we go. Let's try one more with this pattern, and then we'll be good to go. All right, let's try this one. All right, so again, if you're somebody who can't stand f of x, cross it out, put y in its place, right? Make it an equation instead of a function. All right, in this problem, a is 3, b is -18, and c is 27. All right, this parabola opens, a is positive, up. So we have a visual, which means our pattern should be going up from our vertex. All right, let's get our vertex. X equals the opposite of b divided by 2 times a. The opposite of b here is +18. Divided by 2 times a is 3, which is 6. 18 divided by 6 is 3. So the x-coordinate of our vertex is +3. Let's plug 3 in to see who y is. Can't avoid that. So 3, parenthesis, plug 3 in and square it, -18 times 3, and then plus 27. Either type that into your calculator, or you're going to get 9 times 3 is 27, minus 54, plus 27, that's -20, plus 27, that's 0. You actually get a y-coordinate of 0, which is fine. You get it? Yeah. So now 3, 0 is your vertex. Throw it right on the graph. Right 3, up or down, none. Let's get our AOS, that imaginary vertical line that goes right through the vertex, cuts the parabola in half, and says everything on the left and right side has to match. All right, the equation will be the vertical line, x equals, what is the x value that never changes on that line? 3. All right, now you're at a crossroads. Now you make a choice. Are you a pattern person or are you a table person still? And it never matters. It doesn't matter to me. I need you to do what you are comfortable with. If you're a pattern person, you're going to put your vertex in the middle, pick 2 to the right, 4 and 5, pick 2 to the left, start plugging numbers in. Or, let's get ready for that pattern. In this problem, a is 3. because you need A. A is what the pattern revolves around. So now we're going to need some 1A, and some 3A, and some 5A, and some 7A, but really just 1A and 5A. Oh, I'm sorry, 1A and 3A. All right, well, what's 1A? 1 times 3 is 3. So that's the first number of jumps you'll make. 3 times A is 3 times 3, that's 9. That's the next number of jumps you'll make. All right, let's do it. Guys, A is positive, so we're going up with our pattern. So go to your vertex. Move to the right 1 space to the next X value. We're making 3 jumps first. 1, 2, 3. You can match it on the other side or go left 1 and jump up 3 to match it. All right, now from this point, do not go back to the vertex. From this point, I actually think it goes off the graph by a couple. Yeah, it does, right? All right, so now we're going to go from this point to the right 1. Now we're jumping up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes off by 2. And then we're going to go left 1 and up 9 and match it. And then there's your parabola. Right, the bigger A is, the bigger and skinnier it's going to get. All right, everybody okay? Yes? All right, let's fill in some information. Does this parabola have a max or a min? Well, guys, I can see this parabola. It's going to go up, and it's going to get big and go on forever. So it doesn't have a max, but it definitely has a low point, a minimum. All right, the y-intercept. The y-intercept is not shown on our graph. So we're going to have to calculate it. Every y-intercept always has an x-coordinate of 0. That's what puts it on the y-axis. So all you have to do is plug x equals 0 in and see what number comes out. Guys, this is beautiful. 0 squared, 0. 0 times 3, 0. This is gone. Negative 18 times 0, 0. This is gone. 0 minus 0 plus 27 is 27. All right? The x-intercepts, or the roots. This parabola only hits the x-axis 1 time, and it's actually the vertex. It's 3, 0. The domain is always all real numbers, and the range, it looks like all the y's are up here, but the smallest one is 0, and then they're all bigger than 0. So y is greater than or equal to 0. And we're done. How do we feel, okay? How many of you think you would use the pattern in the future? Yeah?
I was doing it like before you did it,
Mm-hmm.
I'll
Yeah.
see if I get it right.
Yep. Okay. All right. So guys, it's your call now. So tomorrow, I want you guys to be able to practice one last time. And like I said, I'm probably going to give you those Google Slides that you work on the meet. And then on Tuesday, I think it'll be a quiz on these graphing standard form. All right. Good attendance is good? Mm-hmm. All right, guys, we are good to go. Let me know if you need anything. All right. Have a great day.